Okay, last one. Sammy. Sammy's going to hit a tennis ball, and it's going to fall in an arc. And it's going to have a equation where y is the height of the ball. Okay, so here's Tammy, or Sammy. And I hit the ball, usually a tennis ball, I hit about mid-height, if you will. And I'm assuming that that tennis ball is going to go up in the air, over a tennis net, and probably hit the ground. That's my assumption, unless it gets hit by someone on the other side, whoever Sammy's playing tennis with. So, since y is going to be the height above the ground for this lovely ball, why don't we make that y? And since it's above the ground, why don't we make this? Notice I'm not putting the tennis ball on the ground. This isn't golf. You need to know your games. This is also where a baseball would probably be hit, right? If I'm hitting it with a baseball. Okay, cricket would be on the ground. Yeah, all right. So let's take a look here. Mark the x and y axis. Yay. Let's calculate the y-intercept. Well, it's going to be up in the air a little bit. So what we're going to do is we're going to set y equal to 0. No. Not for a y-intercept. Silly me. Again. No. X equals to 0. So it's going to be y equals negative 0.10 plus 0.60 plus 1.6. And what a waste of time that was, right? Because this is a quadratic in standard form. So we know it's a c value. So the y-intercept is simply going to be 1.6 feet above the ground. I'm going to label that. So this is 1.6. So I was right. We're hitting the tennis ball right about there. Yes?
On the test, could we just write, like, reading the c value and just write the 1.6?
Yeah, as long as you tell me that I'm reading the c value. Yeah. Factoring the equation. Now I understand why the studio audience didn't like doing this question. Tough. Get better. Because this is the question I'm giving you on the test and the quizzes. So, no, not the exact one, but ones like it. So, let's common factor. Now, it's 1, 2, 3 terms. Do you see that, people? Let's be honest here. Do you see 1, 2, 3 terms? So it's a trinomial, but it's got a value that's not 1. So we have to common factor first. I'm going to common factor out. I want to take out the negative 0.1. So I'm going to common factor that out of all 3 terms. So it's going to look like this. 0.6 divided by 0.1 is 6, and it's going to be negative 6. 1.6 divided by 0.1 is going to be negative 16. Now, ladies and gentlemen, you have to be able to do that. If you can't do that, you will not do well on the next test and or quiz. You have to be able to do this. So, now I'm going to factor the trinomial because I've got a cute little trinomial here. X squared, negative 6x, 16. So, 2 numbers that multiply to give 16, add to give negative 6. I'm thinking 10 and 6, both negative. No, just one negative. Hold on.
Negative 8 and 2.
Yeah, negative 8 and 2. That won't work. Thank you, studio audience. So it's going to be negative 16, negative 6, and we're thinking negative 8 and 2. And so let's check that. Negative 8 and 2 gives me my negative 6. Negative 8 times 2 is negative 16. So this is going to factor out into negative 0.1, x plus 2, and x minus 8. And please do not forget to bring that multiple down. Okay, determine the x-intercepts. Well, what we do is we set y equal to 0. And we use the factored form. So it's going to be 0 equal negative 0.1, x plus 2, and x minus 8, which means that it's pretty easy to see. It's going to be x equals negative 2 and positive 8. We're going to put those on the equation, on the graph up here. So I've got 8, and over here is the -2. Calculate the vertex of the parabola. Okay. Axis of symmetry time. Right through there. Axis of symmetry. So what we're going to do is we're going to take the 8, we're going to add the -2, we're going to divide by 2, we're going to get 3. So x equals 3, therefore vertex is going to be 3 comma k. And we need to determine that k value. So to determine the k value, we're going to take x equals 3 and either plug it into here or plug it into here. It doesn't matter, but I think this one's easier, don't you? So it's going to be y equals -0.1, 3 plus 2, and 3 minus 8. So that's 5 and -5. So that's going to be -0.15, -5. And I think I've done this before. I think it's going to be 2.5, but let's see. It is. Negative times a negative is positive. So my vertex is going to be 3, 2.5, which is way up here. Which means that it's going to hit a maximum height of 2.5 feet, and it's going to be 3 feet after good old Sammy hits it. So, how far away does the ball land? 8 meters from Sammy, or feet probably, feet from Sammy. At what height was the ball hit? Well, 1.6 above the ground. What is the maximum height reached by the ball? 2.5 feet above the ground. Yep. If the net is 4 feet away and 3 feet tall, does the ball clear the net? Da 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 da. So, if the net is 4 feet away from Sammy, so 4 feet away, let's see, this was 3 feet, so 4 feet's here, and we're going to give it a height of, what did we say? 3 feet tall? So the question is, does the ball go over that, or does it hit it? So, does it? How do you know?
Because the vertex is above it.
Ah, the vertex is 2.5. That's the highest point, isn't it?
Oh.
Which is 2.5. So if this is 3 feet, it's higher than the vertex. So guess what? Sammy does not clear the net. No, Sammy is sad. So the question is, how tall, how high up is the ball at 4 meters away from Sammy? And we can determine that by using the height of the ball 4 feet from Sammy is given by, so we take that 4 and we plug it into the equation. Where do you want to plug it in? Do you want to plug it into the standard form or into the factored form or the standard form? Factored, okay. So the height will be y, -0.1, 4 plus 2, and 4 minus 8, which will be -0.1, 6, -4. So I think that's going to be, I can't do that in my head, 4 times 6 times 0.1, negative times negative, 2.4 feet above the ground. That's below the net, isn't it? The net's higher than that, so that's not going to work. What you could have also said there, and I would have accepted, was, hey, it's after the vertex. The vertex is 2.5 feet in the air. Therefore, anything, everywhere on this serve of Sammy's is going to be lower than that 3-foot net. So Sammy's out of luck. It's not going to happen no matter where he is. I would have accepted that too. All right, that's it for that one.